Hey guys, CJ here from Elevated Systems, and welcome to part 2 of my video on how to rewire a PC case. If you haven't seen part 1, you can check it out right here. In that video, I modified power supply cables by trimming the 24-pin ATX cable, splicing in the SATA power, and extending the EPS power cable. In this video, we'll be trimming up the front panel I/O cables. So, let's roll the opener and get started. Just a quick setup recap. Today, we're working with the In Win Chopin mini ITX case, but the techniques I'm going to cover can be applied to any PC case with front panel I/O cables that may need to be modified. Next, in an effort to cut down on recording time, I'm going to plug in the introduction to the tools and supplies we'll be working with directly from the part 1 video. If you've already seen part 1, feel free to skip ahead to this point right here. So the first thing I'm going to do is show you all the tools and supplies I'm going to be using to do this job, so I don't have to explain each one as I get to it. So the first, of course, is a good pair of wire cutters, and I have these standard side cutters or flush cutters, just a standard tool in a PC build. Next, I have a wire stripper. I use one of these auto strippers because it's easy. These can be a bit more expensive than a standard wire stripper, say like this one. But this one is actually pretty cheap. The length guide doesn't really work, and sometimes the lock doesn't lock, but it does what it's supposed to do. It strips the insulation off the end of the wire with zero effort. Just insert, squeeze, and strip. Not too complicated. The next thing I have is a ratcheting crimper. I have 2 of these. The orange one is for ATX connectors and has a 1.5, a 1mm, and a 0.5mm crimp channel, while the blue one I use for DuPont connectors and has a 1mm, a 0.5mm, and a 0.25mm crimp channel. You also need some type of pliers. A standard pair of needle nose works great. I use the ones on this. Also, a very helpful tool that you just saw is this pin puller. I also have an X-Acto knife and a lighter. And finally, I have my soldering and rework station over here, but just a simple, inexpensive soldering iron will work. Now, for supplies, you'll need some female DuPont connectors used for the front panels. I also have an assortment of DuPont housings and an assortment of some heat shrink. I'll leave links to all this stuff in the description below. The front panel cables are easier and harder to modify than the power supply cables. Easier because all the wires in the cables are color coded, so you can just lop off the end without worrying about the pinouts. And harder because the smaller DuPont pins we'll be using can be harder to work with. So let me start by introducing you to a DuPont pin, which is basically a small version of an ATX pin. The only other differences are the insulation crimp wings are slightly offset and the way it clips into the housing. But as far as installation, it's pretty identical to how we installed the larger ATX pins in part 1. So again, if you already saw part 1 and don't think you need a closer look at the DuPont pin, go ahead and skip to this point. This pin has 2 sets of crimp wings. The bottom larger set of wings wraps around the insulation and digs in a bit. The second smaller set of wings crimps around your bare wire, making the electrical connection. This is also the crimp point that secures the wire to the pin, as the insulation is soft and can tear if it's the main point of stress. Stripping the right amount of wire off the insulation is also important because if it's too short, you won't get a good crimp. And if it's too long, it can extend into the opening, which can then interfere with the male pin being able to be fully inserted. I'll start with the front panel audio. I'm going to route the cable exactly how I want it. Then I'm going to mark the cable just past the connector. Now, I'm going to cut the wire. Okay, so we did the audio cable first because it is slightly different than the rest of our front panel connectors and slightly different than most of the connectors in our computer system. Slightly different than any of the cables we're going to work with because our ground wire, our black ground wire, which connects to the DuPont housing, is not actually a wire that runs through the whole cable. It is our ground sheathing, or the little silver strand wires that run around the outside of the cable itself. So what we're going to do is take some of these wires and splice in our black wires, just like it's done here. If you can see right there, some of our black wire is spliced right into our ground sheathing. So we're going to do the same thing here. So all I did is bunch up just a little less than half of our ground sheathing wires, and I stripped just less than a 1/4 inch off my black 23 gauge wire. And then all I want to do is just kind of merge them together here. That's just it. I want to merge them together. And if you saw part 1, again, this isn't a master class in soldering. Again, I just want just a tiny bit of solder there just to hold these wires together for me. All right, that's ugly, but it'll serve its purpose. Now I'm just going to trim off that excess sheathing, grounding sheathing here. I just want to cut that black wire flush with the rest of them. All right, now I can strip about that much off of each wire. And again, how much is that? Well, it is the exact length of our bare wire crimp wings on our DuPont pin. And again, I'll put an overlay right about here so you can see exactly the length of the wire. Okay, now I'm going to pre-crimp my DuPont pins, but I need to point out an oversight I made in part 1. When I showed you how to crimp the ATX pin, I made the assumption that all crimpers are configured exactly the same, which isn't true. I showed you how to do it with the crimper configured for right-handed operation with the crimp channel on the bottom lever of the crimper. However, the crimper can be configured in other ways. For example, I've configured this crimper for right-handed operation with the crimp channels on the top lever. This means I hold the crimper in my left hand and hold the pin in my right hand on the pin side opposite the wings with the wings facing up. And in this case, I'll set the pin on the front crimp shelf of my 1mm crimp, which in this case is the front, with the insulation wings on the wider part of the shelf and the bare wire wings on the narrow part of the shelf. And notice how the bottom of the pin is flush with the tool. Now if I squeeze the crimper all the way and release, this will give me a good start to my crimp. Now, if you're a lefty and you're more comfortable holding the pin in your left hand, you can simply remove the crimp teeth, spin them around, and now you can approach the tool in the opposite direction. And finally, you can swap the teeth from top to bottom. Again, spinning them for your preferred handed operation. Now, I can slide the pin into the channel with the wings facing down until the larger wings catch that lip between the two crimp depths, and then perform my crimp. This is how I prefer to use the tool, but again, it's all about preference. No matter how you set up the tool, as long as you hold the pin firmly so it doesn't rotate or move, and squeeze slowly but firmly, you should get a good crimp. Now that I have my crimp started, I should be able to slide the pin onto the wire, and with the pre-crimp, it should hold pretty well. So now I will slide that pin back into, this time, my 0.25 or 1/4 millimeter crimp channel. And give it a full crimp. Now you want the insulation to go all the way up to, but not into, the second set of wings. And then you can see that that set of wings is slightly offset, but gets a good crimp into that insulation. Okay, I'll take you through that process one more time, then I'll cut away and finish the rest of them. So, I have my pin in my 1 millimeter crimp channel. I'm gonna go ahead and give it a full crimp to pre-crimp that one. Now, I'm gonna slide it on my next wire. All right, once I got it on, give it a full crimp in my 825. All right, got a good crimp there. All right, and that's it. I got 7 more to do, and then I'll be right back. Okay, now I have all my DuPont pins on. Before I finished up all my DuPont pins, I slid on a 1/4 inch diameter piece of heat shrink, just because it's easier to do before all the pins are on than after. And now I need a 5x2 DuPont housing. However, there are only 9 wires. Usually, connectors that don't use all the pins, the empty sockets, are plugged. So you can't plug it into the board backwards. This is known as keying. So to block the empty hole, I'm just going to insert a male DuPont pin into the correct hole, insert my pin, and now I'll just take my flush cutters and I'll cut the end of that male pin off, and voila, I have a plugged housing. Now, plug the pins into the housing using the old end as a guide, ensuring the crimp side of the pin is facing the tab on the housing. Slide the pin in until it clicks. all plugged in. Now I'm just going to slide my heat shrink up, get as close to the housing as I can. Unfortunately, I don't really have a size, and there's not really a size that can both cover the housing and shrink to the cable to give it a nice clean look. So I'm just going to use the 1/4 inch and get it as close as I can. Again, I use my heat gun for this just so I don't accidentally bubble the heat shrink, but a lighter will work just fine. Because with my heat gun, I can dial in the exact temperature, which is around 225 degrees, to shrink this heat shrink. It gets it nice and shrunk without bubbling it up like a lighter can. And that's it. Now I have a perfectly lengthed front panel connector that'll route perfectly, no extra slack, no extra cable to have to bunch up, find somewhere to hide. All right, now I'm gonna do the same exact thing with my front panel connectors. And again, it's the same exact thing. This one's easier because there's no ground sheathing. So I'm gonna grab my case again. All right, now you can see with my front panel connector, there's only just maybe a couple inches I can trim off. That's really not necessary. That's a lot of work for just a couple inches of wire, but I'm gonna show you a neat little trick with this. So instead of trimming this, what I'm gonna do is just change out this DuPont connector, these DuPont connectors. So instead of having all these individual connectors, which can be tricky, especially in this case, to connect to my front panel connector here, I'm gonna take a 5x2 connector. I wanna key it correctly, so again, I'm gonna take my pin. What I didn't show you the first time is that before I inserted that, I actually did crimp it down. So my top one over here is the one with no pin. That's the keying pin for my connector. It's the all right, again, cut that off flush. Now, I can take off the individual DuPont connectors I have here by simply prying up these little tabs, pulling out the wire. Now this is usually destructive. This is a destructive method. Once you pry up this tab, it usually just breaks, and you can't use that DuPont connector again. This is my power switch. It's gonna go here and here. The next two are my power LED, the red, of course, being my positive wire, orange, the ground. So it'll be orange and then red to line up with my power LED here. And then my hard drive indicator LED, which in this case, the yellow is my positive. It'll be just directly under here. Green. And yellow. Now, I have one single connector that I can plug directly into my front power connector. Plug that in. One connector. Simple, easy. Since I've keyed it, basically filled in that hole, I can't connect it in backwards because that'll get in the way. Now, If you need to extend one of your front panel I/O cables, you can apply everything I just showed you to create your own extension cable. Since I split this video into 2 parts, I have some time to give you guys a sneak peek at a future video I'll be doing on creating custom sleeved cables. And I'll be doing that by making a custom sleeved USB 2.0 extension cable. So to start, I'm gonna prep my DuPont housings. These differ from ATX housings as there's not a separate male and female housings, there's just a single gender neutral housing. For a USB 2.0 cable, there are 8 wires. However, we use a 5x2 housing. Pin 9 and 10 are just for keying. Again, to make sure you plug the cable in the correct direction. Pin 9 is inert and pin 10 is plugged. I'll start by lining up what will be my male pin connector with my front panel USB cable. And then I will plug the appropriate hole, which is pin 10, just like before, using a male pin. And flush cutting off the end. I'll mark what will be pin 1, in this case, which will be the red wire. Next, I'll line up my female pin connector and again plug what will be pin 10 and mark pin 1. Now onto the wires. For front panel connectors, I use 23 gauge hookup wire. I'll cut 8 wires to the length I need, which conveniently I've done in advance. Now I'll install the male connector pins on the end of each of the wires. Okay, now I've installed a male pin on each of the wires, and then I went ahead and plugged them all into the DuPont connector. Notice the male pins protrude through the end. I prefer to use all black wire here for a nice clean look. However, this will make lining up the wires and connecting them in the right order on the opposite end impossible once we add the sleeve. So prior to that, we need to mark the wires. What I do here is mark each wire with the appropriate color using paint markers. The first wire, pin 1, gets a red dot. And then I'll mark white, green, and I use silver to indicate the black wire. And then for what is essentially USB port 2 will be 2 dots, 2 red, 2 white, 2 green, 2 silver. So with the wires all marked, let's move on to the sleeving. I'm using MDPCX small sleeving, the liquid carbon, I think. This is the type of sleeving I pretty much use exclusively at this point. It's quality stuff. I've already pre-measured and cut this piece slightly longer than my wires. Longer because since I'm going to be sleeving all 8 wires in this single sleeve, it'll expand. And as it expands, it shrinks. Getting it exactly right is well, more of a science than an art, because I'm sure there's a precise mathematical formula to figure it out, but I'm not smart enough for all that. I just go with yep, that looks about right. So, to make it easier to get all 8 of the wires through, I'm going to take a small piece of 1/4 diameter heat shrink and shrink it on the end of all 8 of these wires here. Now, I can feed the wires through the sleeve. All right, now I can add 2 pieces of 1/4 inch heat shrink. Just slide those on. Now I can take this piece of heat shrink off. I'm just going to slide back the sleeve just to get it out of the way. I'm going to hold it in place with a clip. And now I'm going to install the female DuPont connectors. Okay, now with all the pins installed, it's time to clip them into the housing, making sure you install them in the correct order. You notice the female pins don't protrude from the housing. Going to remove the clip, sleeving, and then finally I'm going to shrink each piece of heat shrink on the end. And that finishes off a nice, clean looking extension cable. You can also sleeve the rest of your front panel connectors in the same way if you desired. Basically, all front panel connectors can be modified this way. If the case had the USB 2 cable, we could trim it the same way, but we can't modify the USB 3 cable. Messing around with the high-speed USB 3 cable is not a good idea. These cables are manufactured in a very particular way, and the 9 wires that make up each of the 2 cables are grouped and shielded in a very particular way to minimize things like signal loss, reflection, and crosstalk. So trimming a USB 3 cable really isn't an option today. Now, don't get me wrong, you can buy a replacement internal USB 3 cable connector, and if you're determined, you can shorten the cable, but at your own risk. If you cross a 5.5 lead into a high-speed data position, you can say bye-bye to whatever peripheral you just plugged into that port. So now I'm just going to tuck the excess USB 3 cable underneath again, this time a little more neatly, because honestly, this video was less about modifying the wires in this particular case and more about showing you how to do it. You can apply these same techniques to any PC case or to any power supply. A good example of where this is really useful is when adding sleeve cable extensions to your system. Instead of balling up all that excess PSU cable and trying to find some place to hide it, you can just shorten it. Also, fan cables. I didn't cover that here because, well, no fans, but fan cables work the same way. PWM fan pins look a little different at the top end than DuPont pins, but they crimp the same exact way using the same tool. And if it's a proprietary connector, like this thermal take fan, it's exactly the same, as these just use DuPont connector and pins the same as your front panel connectors. I'll also be doing a full video on fan cabling covering 3-pin, 4-pin, and proprietary connectors and hubs. But that's it for this one, guys. I hope you learned something. That, as always, is my primary goal. In next week's video, I'll be assembling or reassembling this mini ITX system, this time slowly and with commentary. So please make sure you hit that subscribe button so you don't miss that. And because it is one of the best ways you can support a small channel like mine. If you like this video, you know what to do, and I hope to see you in the next one.